So this is going to be the Chapter 2 review, and like all of my reviews, I guess this is only the second one, before you get started with the review, watching the video at least, you should probably try to do the entire review, and you shouldn't have to watch every minute of this review. You should only fast forward to the problems where your answer and mine don't match, and if you're able to do a problem correctly, then there isn't anything I can say to make you do it better than you did. So when we get to the test over Chapter 2, I think every formula that I can possibly think that you're going to need, you're going to have. And if you open up the Chapter 2 review on my webpage, you'll see a bunch of formulas, and those are the formulas that will be given to you. And this first problem asks me to use the Pythagorean theorem. That, I say I'm going to give you every formula. That might be the one that's not on there. The Pythagorean theorem, I think most everybody knows, and I didn't take the time to write that on there. But every other relation that I can think of, I think is on there. So this problem number 1a is easy because the letter that's unknown is marked with a letter from the Pythagorean theorem. So I'm going to call this side A, and then this is the right angle, so the side opposite the right angle is the C, and I need a B, so this side with the 7 is going to be B. Generally we want to have units in our answers, and if I can't find a picture that has a unit, I tell you in the header what the unit should be. So my answer is going to be A equals something, and it's a length of a side, so it's going to be in centimeters, and it's not going to be in square or cubic centimeters. Apparently the answer is 8.49 because I took that from the answers. I don't know if I have them here. Yeah, I didn't bring them. But anyways, the last page of this, the answers are there, and I just copied the answers onto the sheet to make sure I wasn't going to make a mistake on my video. It says to round to 2 decimals. There's a 2 decimal answer. Let me just get there. So I'm going to go a squared plus 7 squared equals 11 squared. That's going to give me a squared plus 49 equals 121. Then I'm going to go minus 49 minus 49 to, I think that's 72. You could do that on your calculator. So this gives me a squared equals 72. Then I go the square root of a squared equals the square root of 72. And at some point I'm stuck using my calculator, and this is when I'm going to pull it out. But you can use your calculator the whole time through. So I just need to do the square root of 72. So second square root 72, and then I get square root of 72 is 8.485. Because it says to round to 2 decimals, when I write down my first stab at the answer, I'm going to carry 3 decimals. If the number in the third decimal place is 5 or bigger, you round up. Because that number in the third decimal place is a 5, I'm going to round that 8 up to a 9. So the numerical part of my answer is 8.49, and then the unit part of my answer is centimeters, because the lengths are linear units. They don't have squares or cubes, and I've told centimeters. And you could write the word centimeters as well. You don't really need the A equals. If you just wrote 8.49 centimeters, that would be fine. Part B, it calls the unknown side X. This is still a right triangle. The right angle is up here, so this X is working like a C. And then the other 2 sides are interchangeable. I'm going to call one of them A and one of them B, and it really doesn't matter. I'm going to call this side the A and the 4 the B, but you could have just as well called the 3 the B and the 4 the A. You'll get the right answer. What you don't have flexibility of is what side you call C, because C is opposite the right angle. So now I'm going to pull out the Pythagorean theorem. A squared plus B squared equals C squared. And for the A, I'm going to put a 3. And for the B, I'm going to put a 4. And then for the C, I'm going to put an X, because that side is called X. This is going to give me 9 plus 16 equals X squared. That gives me 25 equals X squared. So the square root of 25 is going to equal the square root of X squared. Usually when you take square roots, you need a plus or minus, but you don't in this case because this is a length of a side and you can't have a negative length. The square root of 25 is 5. The square root of x squared is x. So for my answer, I need units, and the same instructions apply to this problem that did for part 1a. So the units are going to be centimeters. I think the last part of number 1 is to find that D, which means diagonal of a rectangle. And when I do this problem, I'm only going to look at half the drawing. I'm going to look at the top half of the drawing. And I'm going to have a triangle that has a right angle. The legs are 10 and 16, and the hypotenuse is called D. So again, for my a squared plus b squared plus c squared formula, the side that's opposite the right angle needs to be the C, and then the other sides are interchangeable in terms of being A and B. I made the A10 and the B16. You can make the A16 and the B10. I'm going to take those values and go a squared plus b squared equals c squared. Plug in 10 for A, 16 for B. Again, you could have 16 for A and 10 for B. And I'm going to plug in D for C. So now this is going to give me 100 plus 256 equals D squared. So I get 356 equals D squared. I get the square root of 356 equals the square root of D squared. That's going to give me D equals, and I'm going to carry 3 decimals. So I'm going to do second square root 356, and I get 18.867. Again, if I'm rounding to 2 decimal places, I need the number in the 3rd decimal place. The number in the 3rd decimal place is 5 or bigger, you round up. So that I'm going to round up. Look at this, I'm getting a completely different answer, which means I made a mistake somewheres. Because without using my calculator, I may make mistakes. Well, I make mistakes even with my calculator. Let's try this. 10 squared equals, and then 16 squared equals, and then 100 plus 256 equals, and then second square root 356 equals 18.86. I believe this, I don't see a mistake here. So I think the answer that I wrote down here was wrong, which is nice that I'm catching that. So that answer doesn't feel good at all. And I know it's wrong because the hypotenuse is always the longest side in a triangle, so it had to be more than 16. And 12.49 is not more than 16. The hypotenuse in a right triangle is always the longest side, so that doesn't even make sense. So I'll fix that in a second, but for now I'm going to write 18.87 and then attach the units for part 1C. Okay. Number 2, find the perimeter and the area. The perimeter is just of a figure that has straight line sides. It's just adding up the lengths. And the units aren't going to have a square or a cube. They're just going to be linear. So for the perimeter of this figure, I'm not going to include the 11 because it's not along the boundary. I need that 11 for the area, but the perimeter, I'm just going to add the 4 sides, 12 millimeters plus 13 millimeters plus 18 millimeters plus 14 millimeters. That's 12 plus 13 is 25, 35, 43, 53, 57, I think. And you're going to get linear units. Again, I could just use my calculator and go 12 plus 13 plus 18 plus 14 and get the 57. And I put the units on. For the area, the formula that I need is base 1 plus base 2 times the height over 2. What I have right now in the write-up is this. I kind of like this version of the formula better. These are equal to each other. So I'll go ahead and clean that up for you. I think that's the nicer version of the formula. So I'll use that version of the formula, which means I have to identify 3 different sides. And the height is the dashed line. So in this formula, the height's going to be the 11 millimeters. And I'm going to put my units in at the end. It's an area problem, so the area, units are going to be square units, so I'm going to get millimeters squared. And then the base 1 and the base 2 are interchangeable. They're the sides connected by the height. So for base sub 1, I can call it the shorter length of 12 millimeters, but it really doesn't matter. And base 2, I'm going to call 18 millimeters. So my area is going to be base 1 12 plus base 2 18 times the height of 11 over 2. I think I can just do this all in my calculator just so I don't make any mistakes. So parentheses 12 plus 18, close my parentheses, times 11 divided by 2. That's going to give me the right number. It doesn't give me the units because I haven't included any units. And the units, since it's area, have to be square, whatever the units are in the problem, so it's going to be square millimeters. And the same numbers that I have, so I feel good about that. So for a circle, the perimeter is called a circumference, and the instructions say to write my answer in terms of pi. So I need two formulas. The circumference of a circle is 2 pi r. The area for the circle is pi r squared. Both of formulas that I have on this sheet, area and circumference, need the diameter, and need the radius, and I have a diameter. So the radius is going to be half of the diameter, and this length right here is a diameter. The 22 is the d, and my radius is going to be 11 centimeters technically. When I go to do my answer, the units in the circumference are going to be linear. The units in the area are going to be square. So circumference is going to have centimeters, area is going to have square centimeters. And then the algebra that I need, I'm going to go 2 pi times 11 for the circumference. And then it says leave pi in my answer, so I'm just going to multiply the 2 and the 11, and I'm going to leave the pi. And I'm going to write 22 pi centimeters for the circumference. And then for the area, I'm going to go area equals pi times 11 squared. And 11 squared is 121. So that's going to be 121 pi centimeters squared. And that answer doesn't feel right either. It's kind of disturbing. Check this out again. So need to find the radius. Radius is half of 22, which is 11. Circumference 2 times pi times 11, 22 pi feels good. Area 22, 11 squared. Those feel really good for area and circumference. So area should be written as 121 pi centimeters squared. I usually use A for area just to speed up the process, and C for circumference. Alright, first find the length of the unknown side, and then find the perimeter and the area. So first the unknown side, this is a right triangle. The side opposite the right angle has to be called C. The other legs are interchangeable for A and B. I'm going to call this unknown side for now, I'm going to call it B. Now I'm going to use the A squared plus B squared equals C squared formula. And for the A squared, I'm going to put 5 squared. This side didn't have a name, I'm just going to leave it as a B for now. And then for the C side, I'm going to put 13 squared. So this is going to give me 25 plus B squared equals 169. And then minus 25 minus 25. This gives me B squared equals 144. So the square root of B squared equals the square root of 144. And I get B equals to 12. And it says the lengths are in inches, and it's the length of a side, so it doesn't get a square. So part of my answer is going to have 3 different parts for it. I don't need to call it a letter, but I need to give something. So for the missing side, which I could say it's B or A, I'm going to say that's 12 inches. So this is a 12, and if they're all inches, 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 inches. The perimeter of a triangle, you just add up the three sides. So the perimeter, which is P, is going to be 12 inches plus 5 inches plus 13 inches. I think that comes out to 30. And it doesn't get a square. So perimeter, I use the letter P. I attach the number 30. And then the lengths of the sides are in inches. And perimeter doesn't get a square. You just get a regular inches. And then the area for a triangle, probably the nicest formula is base times height over 2. And so I'm going to use that formula for the area of the triangle that's equal to half the base times the height, but base times height over 2 is probably easier to work with. And the base and the height is the length that goes from one corner to the other side that forms a right angle. So the B is going to be the height. So my height is going to be my 12, and my base is going to be my 5. They're really inches. So area is going to be base times height over 2. Technically, it's 5 inches times 12 inches over 2. That's 60 over 2, which is 30. So the area has the same number as the perimeter, but it doesn't have exactly the same units. Area always gets square units for my answer. So notice how I did all the computations without putting the units in, and I throw them in at the end. That's maybe not the best practice, but when you know what the units at the end should be, and we don't have any bizarre things going on where sides have one side is inches, the other side is centimeters, I just leave my units out until the end and then toss them in. Okay, find the shaded area. So that's kind of a two-part problem. Leave my answer in terms of pi. So first, I'm going to find the area of the unshaded part. And that's that circle in the center with a radius of 3 centimeters. The area formula for that is pi r squared, and so it's going to be area is pi times 3 squared, and it's going to be 9 pi, and it's technically centimeters squared. Second, find the area if the whole figure was shaded in. So find the area of this big circle. So pretend this is all shaded in. The second, find the area if the entire region was shaded. And that would be the bigger circle that has a radius of 7 centimeters. Same area formula. The area for this is going to be pi times 7 squared, and that's going to be 49 pi for the numerical part, and the units are going to be 7 centimeters squared. The last thing I need to do is subtract these. So you subtract the bigger number minus the smaller number. So the final area that I need is going to be the 49 pi centimeters squared minus the 9 pi centimeters squared. And the pi centimeters squared part won't do anything. It's going to stay the same. I just have to subtract the 49 minus the 9. And that gives me 40 for the numerical part, because 49 minus 9 is 40. I leave the pi, and I leave the centimeters squared. It would be nice if I would have written area equals, but I can live with that just like that. Same sort of problem. First, I'm going to find the area of the unshaded part. Now it says to use 3.14 for pi. So you have to watch the instructions. The area of the unshaded part's the circle in the center. And that circle has a diameter of 28 kilometers. divide that by 2 and you'll get its radius of 14 kilometers. So the area of my circle is going to be pi r squared. The radius is half of the diameter, so it's 14. And now I'm told to use 3.14 for pi, so it's going to be 3.14 times 14 squared. I'll do that on my calculator. So 3.14 times 14, hit the x squared key, and get the unshaded part is 615.44. The area is 615.44 kilometers squared. And now find the area of the entire shape. That is, if everything was shaded in, if this whole thing was shaded in, that would be the area of a square. So if the whole thing was shaded in, I'd have a giant square of 28 kilometers on each side, and the area for a square is just side squared. So the area formula that I would need is multiply the sides together, and the sides here are 28 by 28. I'm assuming that's a square. So the numerical part of my answer here, I'm going to do 28 squared, and I'll get 784 kilometers squared. And then lastly, subtract the bigger amount minus the smaller amount. So the final answer, the area that's originally shaded, is 784 kilometers squared minus 615.44 kilometers squared. Apparently, hopefully that's 168.56. So 784 minus 615.44, and I get 168.56 kilometers squared. So that's my answer for the shaded area in the original problem for number 6. All right, for problem 7, using 3.14 for pi again, rounding to 2 decimals, assume the lengths are in centimeters. First, find the area of the unshaded. And each of the unshaded regions, there's 2 kind of unshaded regions, each is a triangle. And I'll find each of the areas and add them together. So each of the triangle and the height and the base of each triangle is 4. So I have 2 triangles. The triangle that looks this way, kind of upside down one, has a height of 4 and a base of 4. And then so the area of that is the base times the height over 2, which is 16 over 2, which is 8. Units are centimeters, so it's 8 centimeters squared. That's kind of the bottom triangle. The top triangle has a base and a height of 4 as well. Its area is 4 times 4 over 2 again, which is 16 over 2, which is 8 centimeters squared. I'll add these together. So I'll take the 2 unshaded triangles and get 16 centimeters squared for the unshaded area. So that's the first part. Now I pretend this whole thing was all shaded in. So now I'm going to find the area of the entire shape. And that's just a big old circle with a radius of 4. And the area formula for a circle is pi r squared, but I'm told to use 3.14 for pi. So it's going to be 3.14 times r squared, which is going to be 3.14 times 4 squared. Calculator time for that. So I do 3.14 times 4 squared, and I get 50.24. And then the units I have to be square than centimeters. And for my final answer, I subtract. So I'm going to take this minus this. Now subtract. The bigger minus the smaller number. So the final area is going to be 50.24 centimeters squared minus 16 centimeters squared. So it's 50.24 minus 16, and I get 34.24, and then I have the units on. So my answer, the shaded area for this, is 34.24 centimeters squared. Alright, now on to the volume. So I need to know that that is a cylinder of some sort. Actually, it's a right cylinder, but I'll just call it a generic cylinder. The volume formula that I need is pi r squared h. Told to leave my answers in terms of pi. So I'm going to use volume is pi r squared h. My units for volumes are going to be cubic. So when I go to write my answer, my units are going to be cubic feet. And I'm not going to include the units in my computation. I'm going to put V equals, I'm going to leave the pi. The R is the 3 feet, so I'm going to get 3 squared. And the height is the 11 feet, so I'm going to get 11 squared. So this is going to be volume equals pi. Do exponents first. 3 squared is 9 times 11. And then 9 times 11 is 99. And I'm told to leave the pi and not make it into a 3.14, so volume is going to be 99 pi. But in my answer, I need to have units. I neglected to use my units in the write-ups because they weren't necessary, because I knew what they were going to be. And so my answer should be 99 cubic feet. 99 pi cubic feet. This is a sphere. And the volume formula for a sphere is 4/3 pi r cubed, and the r is that. So I need the formula. Volume is 4/3 pi r cubed. Leave my answers in terms of pi. So volume is going to be 4/3 times pi times 11 cubed. And then I know my answer, the units have to be cubic because it's volume. And because the length is in meters, I need cubic meters. I know I'm going to have a pi in my answer because I'm told to leave the pi. I just have to figure out what 4/3 times 11 cubed is. And it doesn't say whether to give a decimal or a fraction. I probably prefer the fraction, but I'd live with a decimal. So to do this, I'm going to go parentheses 4 divided by 3 and then times 11 up arrow cubed. If I wrote 174.67 rounded to 2 decimals, I'd live with that, but hitting math and enter twice, making that into the fraction, 5,324 over 3 would seem better. Not the answer that I have at all down here. That's interesting. 5,324 over 3. That makes sense. Where did I get this 44 from? I'm glad I'm doing this right now because my answers that I had written down weren't feeling super accurate. So this would be a nice answer, or 1774.67 pi meters cubed. Both would be fine. I don't even know where you get this 44 from that I had down there. I can see the over 3 in the pi part. Interesting. Alright, so that feels good. So I get the right volume formula. The shape is a sphere. Volume for a sphere is 4/3 pi r cubed. I don't have that memorized, so you're going to be given that on this whole sheet here is going to be replicated on your test, at least what you need from that sheet. Plug in 11 for the r, do the math, broke out my calculator, did 4/3 times 11 cubed. Let me just do the 11 cubed first and see if that matters. 11 up arrow 3 times 4 divided by 3 equals same number, math, enter, enter, 5,324 over 3. Perfect. Best answer, okay answer. When it doesn't say round to 2 decimals, I prefer the fraction. And if it says leave the pi in, leave the pi in. This is a harder problem. I can hardly draw this. What I need to do is find the area of the top and the bottom separately. The top is a triangular prism. So I'm going to first find the area of the top. figure, which is kind of like the roof of a house, that's a triangular prism. And so to find the volume of a triangular prism, the formula is half the base times the height times the length. So I need to do the top part. The volume formula is half the base times the height times the length. The base and the height come from the triangular part. And so the triangle part of this, if I look at the other side, I see that it has a height of 2 meters. So the height in this formula is going to be that 2 or this 2. The base needs to be this length right here, and that 5 down there is going to come up here and be another 5. So the base is going to be a 5. And then the other length that I haven't talked about, these lengths, this length, or that length, or that length, that's the length part, and that's this 6 from down here. So the volume for the top is going to be a half times the base, which is 5, times the height, which is 2, times the length, which is 6, all in meters. So the volume for this is going to be in meters cubed. And then I can do this on my calculator. So I'm going to go parentheses 1 divided by 2 times 5 times 2 times 6. I should get 30. Well, if I type it right, I get that. So if I'll do parentheses 1 divided by 2 times 5 times 2 times 6, and I get 30 meters cubed. Now I'm going to do the bottom part, and then I'm going to have to add the 2 together. So the bottom is just a rectangular prism. So this bottom part, that part down there that I'm trying to designate in a different color, the bottom is a rectangular prism, and that's the easy volume. It's length times width times height. So the volume for the bottom is length times width times height. And this figure that I made in orange has 3 lengths on it. One's a length, one's a width, one's a height. It doesn't matter which you're going to call each, so I'm just going to put them in order. So I'm going to go volume equals 5 times 6 times 3 2/3. And for the 3 2/3, I'm going to go 3 times 3 is 9 plus 2 is 11. So I'm going to go 5 times 6 times 11/3. 3 times 3 is 9 plus 2 is 11 over 3. And its units also going to be in cubic. So I'm going to go 5 times 6 times 11 divided by 3. So 5 times 6 times 11 divided by 3 gives me 110. So the bottom has a volume of 110 cubic meters. The top has a volume of 30 cubic meters. My total volume is going to be the 30 cubic meters of the top plus the 110 cubic meters of the bottom. And for my answer, I'm going to get 140 meters cubed for my volume. All right, now dimensional analysis. We're within the metric system, so that's a decimal moving one. So I need to find meters and centimeters and figure out how far they're apart. So here's meters, here's centimeters, and so I'm going to move my decimal 2 places. It's always the opposite direction. So in this one, to go from meters to centimeters, on my chart, they're 1, 2 to the left, which means I need to move my decimal 2 to the right to do that conversion. So to go from 24 meters into centimeters, I take the decimal and move it once, twice to the right. So now my decimal is going to be here. And any place I move a decimal that doesn't have a number to go in its place, I have to fill with zeros. So this is going to be 2,400 centimeters. To do from 2 quarts to milliliters, these are not units that I have at all. So I go through my volume and I look for quarts. I see quarts with liters, which is good. I see quarts with pints. That's probably not so great. So I'm going to do this in 2 steps. first I'm going to go from quarts to liters, and then I'm going to go from liters to milliliters. If you get the answer using another path, I can completely live with that. And because these units are a little bit rounded, you might get the answer differently, and it might be just a decimal off, and I can live with that. So if you followed a different path, because all these units are rounded, you have room for error, for slight discrepancies in our answer. So I'm going to first convert to liters. So I'm going to go from 2 quarts and get to liters. So I want to end up with liters and get rid of quarts. In the denominator, I put what I want to get rid of, which is quarts. In the numerator, I put what I want to end up with, which is liters. And I know that 1 quart is 0.95 liters. So I'm going to have 1 quart and 0.95 liters. The quarts are going to cancel. I'm going to be left with 2 times 0.95. I don't need the over 1 liters. So that's not going to get the answer, but it's going to be a lot closer to the answer. So now I have 2 times 0.95, which is going to make me 1.9 liters. So the next thing I need to do is change 1.9 liters into milliliters. Easy enough to do because within the metric system it's just moving decimals. So I go to my chart. I want to go from liters to milliliters. And again, I follow the direction. It's 1, 2, 3. I had to go left to get from liters to milliliters. Means I need to move my decimal to the right and 3 units to the right. So I'm going to take my decimal in the 1.9 liters and move it once, twice, 3 units to the right. So my decimal's going to go there. The units now are going to become milliliters, and I need to fill in my zero. So it's actually 1900 point milliliters, but you don't usually write a decimal if it's the very last thing that's written and there's nothing after it in terms of a number. So the best answer for number 12 would be 1900 milliliters. Okay, 13 wants me to change from feet to kilometers, and as I look at this, there's our lengths. The only length that I see has kilometers to miles, so that's not going to be enough. I'm going to have to use 2 units here, and the first thing I'm going to do is get my feet to miles and then my miles to kilometers. I'm going to use both of these units, and I can do them all at once because they're not within the metric system, any of them. They're all crossing, or either within the standard system and then crossing over to the metric system. So I'm going to use those 2 units, and the first fraction that I'm going to put is going to get rid of the feet. And the one that gets rid of the feet is 1 mile is 5,280 feet. So I'm going to use the 5,280 feet in the denominator, 1 mile in the numerator. And what that's going to do is get rid of the feet and get me into miles. Doesn't get me into kilometers, it gets me into miles, so I need to use the other unit. That 1 mile is 1.6 kilometers to get out of the miles. So now I want to get rid of the miles and end up in kilometers. So I'm going to put miles in the denominator to cancel out the miles, kilometers in the numerator, and the unit that I have is 1.6 kilometers is 1 mile. Now the miles are going to cancel, so what I have left, I don't need the times 1, is 10,560 times 1.6 over 5,280, and my units now are left in kilometers. So I'm just going to go times and divide. So 10,560 times 1.6 divided by 5,280, and I get 3.2, and the units are miles. So my answer, for kilometers should I say, 10,560 feet are 3.2 kilometers. Okay, 2-part problem, 14. I have a pool that's a rectangular prism, I'm assuming. First find its volume. And the volume of a rectangular prism is length times width times height. And this is the length, that's the width, this must be the height, even though I call it the depth. So the volume of the pool has to have cubic units. The units in the original problem are feet, so the volume is going to be in cubic feet. And the number part is going to be the length, which is 20 feet, times the width, which is 20 feet, times the depth, which is the height, which is 4.5 feet. Use my calculator for that. Go 20 times 20 times 4.5, and I get 1,800 cubic feet for the volume. That's all there is for part A. Part B wants to know how many gallons of water it can hold, and what I need to do is I need to change 1,800 cubic feet into gallons. And I do that by using a unit that's given to me. The unit that's given to me that relates gallons and cubic feet is 1 cubic feet is 7.48 gallons. I'm going to put the 7.48 gallons in the numerator because I want to end up with gallons. I'm going to put 1 cubic feet in the denominator because I want to get rid of cubic feet. So I'm going to take 1,800 cubic feet, multiply it by a fraction. The 7.48 gallons is going to go in the numerator because that's what I want to end up with. And the 1 cubic feet is going to go in the denominator. I want to get rid of the cubic feet. So now my cubic feet are going to cancel, and I just have to multiply 1,800 times 7.48, and my units are going to be the gallons that they need to be. So now I'm going to just go 1,800 times 7.48, and I get 13,464 gallons for that pool. So that would be the answer to 14B. 15. A car is traveling at a speed of 60 kilometers per hour, miles per hour. What's the speed in kilometers per hour? The per hour part is a distractor. I just need to convert 60 miles to kilometers. So all I have to do is take the 60 miles in 1 hour and convert it to kilometers. And the units I'm going to use for that I've used already. I'm going to use that 1 mile is 1.6 kilometers. And so I'm going to do the conversion. I'm starting with miles. I want to end up in kilometers. So the fraction that I multiply by is going to have what I want to end up with, kilometers in the numerator, and what I want to get rid of, miles in the denominator. The 1.6 is the kilometers, the 1 is the mile. So I put 1.6 next to the kilometer, 1 next to the mile. I cancel out my miles. Now I'm left with 60 times 1.6. I think that's 96, and my units are still kilometers. So 60 times 1.6, and I get 96. It's going to be kilometers per hour. The distance that you can travel in 1 hour is 96 miles. Its speed in kilometers per hour are 96 kilometers per hour. I don't know if that's proper, so I can say km per hour. I'd like that kmph. I imagine it's correct, but I don't really know the metric system and speed well enough to know that that's right, but I'd certainly live with that because that's what I have written on my key. Alright, write as a Roman numeral. Oh. That's the easy way. So this is going to be 2,156 equals 2,000 plus 100 plus 50 plus 6. So there's the thousands, hundreds, tens, and ones. Pull out my sheet of Roman numerals. 2,000 is mm. So I start off, this is going to have an mm in it. And then to the 100 is a C. So I have a C in it. And then 50 is L. And 6 is VI. So this Roman numeral for 2,156 is MMCLVI. That's the way easy way. You just break the Roman numeral down to its ones, tens, hundreds, thousands, and write what each is as a Roman numeral. So 417 is 400 plus 10 plus 7. 400 is CD, so part of my answer is going to have a CD. 10 is X, so I have an X in my answer, and 7 is VII. So this is going to be CDXVII. 1946 is 1,000 plus 900 plus 40 plus 6. 1,000 is an M. 900 is a CM. 40 is an XL. And 6 is a VI. So this is MCMXLVI. Now the backwards way. Backwards way, we did it with a table. So we're just going to write something for the number. I don't know exactly how I worded that. I was inconsistently inconsistent. So I'm going to take the whole symbol and write it down. MCMLXXVI. It's way too long. Now I highlight the first two letters and write what each is equal to. M is equal to 1,000. C is equal to 100. If the bigger letter is written first, you only bring the bigger letter down and you take its value. The bigger letter is written second, you'd bring them both down. Now I'm done with that M. I'm going to carry over the CMLXXVI. Wrote way too big. Now I look at the CM. C is equal to 100. M is equal to 1,000. If the bigger of the pair is written second, you bring them both down and you subtract their values. So I brought both the C and the M down because the bigger value, the bigger Roman numeral, was written second. Subtract, done with those. Now I'm going to move on to LXXVI. Look at the first two symbols. The L is equal to 50. The X is equal to 10. The bigger letter is written first, so I just bring one letter down and write its value. Take it off. Now I have XXVI. You have a pair, and when you have a pair, you just bring one of the pair down. Each of them is worth 10. Bring one of the pair down, write its value, remove it. Now I have XVI. I look at the numbers here, or the symbols here. X is equal to 10, V is equal to 5. When the bigger one is written first, you bring only one down, write its value, remove it. Now I just have VI. The V is equal to 5, the I is equal to 1. When the bigger one is written first, you bring it down by itself, write its value. Now I'm going to bring the I that's left over. Its value is 1. Now I'm just going to add up these values. So it's going to be 1,000 plus 900 plus 50 plus 10 plus 10 plus 5 plus 1. I think that's 1976. I'm going to do it on my calculator to make sure. So I'm going to go 1,000 plus 900 plus 50 plus 10 plus 10 plus 5 plus 1. I get 1976. All right, two more going this direction, which is the hard direction. All right, so again, I need to leave myself a lot of room, so I'm going to just write the whole number down. DCCXLII. And I look at the first two symbols. The D is equal to 500. The C is equal to 100. When the first symbol is bigger, you bring down just the first symbol. You write its value down. remove it from the list. Now I have C, C, X, L, I left over. When you have a pair, you bring one of the pair down. So the CC, each of the C's are worth 100. Bring down one of the C's, write its value down, remove it. Now I'm left with C, X, L, I. I look at the first two. C is equal to 100. X is equal to 10. The bigger value is written first, so I only bring one symbol down. I write its value, remove it. Now I'm left with X, L, I. And for this, I look at the first two symbols. X is equal to 10, L is equal to 50. When the bigger symbol is written second, you bring them both, the first two down, and you subtract their results. 50 for L minus 10 for X is going to give me 40. Remove, carry over the double I. When you have a pair, you only bring one of the pair down. Each of these i's are equal to 1. Remove it. I have just a single I left. Bring it down, write its value, and now I'm going to add these up. I'm going to go 500 plus 100 plus 100 plus 40 plus 1 plus 1. So 500 plus 100 plus 100 plus, I can do that, but 500 plus 100 plus 100 plus 40 plus 1 plus 1, and you get an answer of 742. Last Roman numeral, then there's some bases to do. So C, D, X, C, I, X. Look at the first two symbols. The first two symbols are C and D. C is equal to 100. D is equal to 500. When the second symbol is bigger, you bring them both down. You subtract what they're equal to. That's 500 minus 100. That's going to give me a 400. Remove them. Now I'm left with XC, IX. Look at the first two symbols. X is equal to 10. C is equal to 100. Just like the last grouping, the second one is more valuable than the first, so I bring the pair down. I subtract their values and get a 90. Cancel them out, bring the IX over. I is equal to 1, X is equal to 10. Just like the last two, the second symbol has more value than the first, so I bring the pair down, subtract their values, and get a 9. Now I just go 400 plus 90 plus 9, and that gives me 499. Now the bases. This is the easier way to go with the bases, because you write the number backwards, and then write each times 3 to some power with some plus signs. So for 22, I'm going to take the 2, the 0, and the 1, write it backwards, and then for each, multiply by some power of 3, and the power that I start with is 0. Then I go up to 1, then I go up to 2, and then you put plus signs between. And again, when I was doing this in the video, I'm sure I did it all in one big step, because that's, you don't need to show the individual steps, but just in case you forgot. So you write the number backwards, put the base times each of the numbers, and then start with an exponent of 0 and go up to your out of the bases, and then with plus signs is between. Then it's a calculator problem. The part that's equal to 0, the 0 part I don't have to do. And so now on my calculator, I'm just going to do this. 2 times 3 up arrow 0 plus 1 times 3 squared. You get 11. And that's exactly what this is equal to. So 102 base 3 is equal to 11 base 10. And for an answer, I don't write the base 10, I would just write 11 down. So 2 more going the easy direction. So for 23, I'm going to write the number backwards. So I'm going to write a 0, a 1, and a 3. And then for each, I'm going to multiply by the base. The base is 4. And now I'm going to put exponents with that base, starting with 0 and working my way up. And then put plus signs between, and then break out my calculator. Again, I would probably not show anything but this final line. This line right here I can get to without showing the intermediate steps. On my calculator, I'm not going to do the 0 part. I'm just going to do 1 times 4 to the 1 plus 3 times 4 squared. So clear 1 times 4 up arrow 1 plus 3 times 4 up arrow 2. And I'm going to get 52 for my answer. So my answer for this, 310 base 4 is equal to 52 base 10. You don't write the base when it's 10. Last one in the hard, easy direction. Write the number backwards. It's 1 and 3. Multiply by the base. Add an exponent starting with 0. Put a plus sign between. I'm going to do it on my calculator. So that's what I need to enter on my calculator. 1 times 5 to the 0 plus 3 times 5 to the first. And I get 16. So the answer for 24, 31 base 5 is equal to 16. Now the backwards one where we need the table. And when we need the table, we need lots of powers. So now I need to worry about base 7, so I need to know some powers of 7. 7 to the 0 is 1 power. First, 7 to the first is 7. 7 squared is 49. 49 is bigger than 43, so my table's only going to have 2 columns. So I'm going to start off with either the original number or the remainder. And I know that that's going to start with a 43 because that's my given number. And I'm only going to have 2 columns to this. It's a really nice problem because there's only 2 powers of 7 that are less than 43. Now I'm going to do my power of 7. And my powers of 7 are going to be 7 and 1. And then the subtracting. And leave myself a lot of room for subtracting here. And then the number for my answer. So I'm going to go 43 minus 7. I could do that on my calculator, but I think I could do it in my head. That's 36. And then 36 minus 7 is 29. I want to go till I get to a number smaller than 7. 29 minus 7 is 22. 22 minus 7 is 15. 15 minus 7 is 8. And 8 minus 7 is 1. I've gotten to an answer that's less than 7. That's going to be my remainder. And the number that I'd write at the bottom of this column is going to be 1, 2, 3, 4, 5, 6 for the 6 times I was able to subtract 7. So in my answer, the first number I'm going to get is 6. Now I'm going to subtract these until I get 0. So I'm going to go the top number up here minus the power of 7. I subtract it 1 time and I get 0. I've used all the powers of 7. I've gotten to 0. I'm almost done. The number that I need to finish up with is the 1 time I was able to subtract the 1. So there's the 61. So 43 base 10 is equal to 61 base 7. My answer has to have the base in it because I'm converting to base 7, and that if it without the base it would say 61 base 10. 2 more of these. Need 56 to base 4, so I need my powers of 4. 4 to the 0 is 1. 4 to the 1 is 4. 4 squared is 16. 4 cubed is 64. 64 is too big. My table's going to have 3 columns. So I'm going to start off with the original number or the remainder, which at first it's the original number, then it becomes the remainder. I'm going to have 3 columns. The first column is going to lead off with a 46. And then I don't know, the remainders are going to come in the second column. My next row is going to have my power of 4. Must do 16 first, 4 second, and 1 last. And then I need to leave myself room to subtract. And then I'm going to get the numbers for my answer. Now it's just subtracting. So first I'm going to go 56 minus 16. 56 minus 16 I believe is 40. It's safer to use your calculator. 40 minus 16 is 24. 24 minus 16 is 8. And I can't subtract because I'm under 16. So I'm going to get 1, 2, 3 subtractions. So I'm going to get 3 for my answer row. I'm going to carry the remainder up. And now I'm going to start subtracting 8 minus 4. So I'm going to go 8 minus 4 is 4. 4 minus 4 is 0. I'm down to 0, so I'm done with that column. At the bottom of the column, I'm going to put 2 for the 2 times I could subtract 4. Carry my remainder up, and I can't go 0 minus 1 because I would get a negative. So I put the X in this column because I wasn't able to do that subtraction. And I put a 0 at the bottom of this column for the number of times I was able to subtract the 1. So my answer is going to be 320 base 4. Last problem. 213 to base 5, so I need the powers of 5. 5 to the 0 is 1. 5 to the first is 5. 5 squared is 25. 5 cubed is 125, and 5 to the fourth is 625, which is too big. I'm going to have 1, 2, 3, 4 columns in my table. So I'm going to start off with the original number or the remainder. Starts off with the original number of 213. I'm going to have 4 columns, one for the 125, 1 for the 25, 1 for the 5, and 1 for the 1. Now I'm going to do my power of 5, which is going to be 125, 25, 5, and 1, and then make my answer down at the bottom. So first thing I'm going to subtract is 213 minus 125. I'm afraid that I can't do that right now. So 213 minus 125 is going to be 88. It's less than 125. I'm done with that subtracting. And at the bottom of this column, I put a 1 for the 1 times that I could subtract, carry my remainder over to the top of the next column, and now I'm going to start subtracting. First, 88 minus 25. 88 minus 25 is 63. Now I'm going to do 63 minus 25. 63 minus 25 is 38. And then 38 minus 25. 38 minus 25 is 13. I'm less than 25, so I'm done with that subtracting. At the bottom of this row, I put 1 column. I put 3 for the 3 times I could subtract. Carry my remainder over, and now start subtracting 5. So 13 minus 5, I don't need my calculator for that, is 8. 8 minus 5 is 3. I'm less than 5, so I'm done with that column. At the bottom of the column, I'm going to write 2 for the 2 times I could subtract. Carry my remainder over to the next column. Now it starts subtracting 1. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. I've used up all the powers of 5 and gotten to 0, so I'm basically done. At the bottom of this column, I'm going to put a 3 for the 3 times I could subtract, and my answer is going to be 1323 base 5. So that's everything that we need for chapter 2. So if you do all the problems on this review, then you should be perfectly ready to do the test. again, come visit me or shoot me an email if there's something you're just not getting like you want to get it, and I can make that better before you take the test. You don't want to learn it after the test. You're much going to